So for this question, I want to show that the derivative of x over tangent 1 plus x squared is equals to cotangent 1 plus x squared minus 2x squared cosecant squared 1 plus x squared. Okay, so I mean, if I'm looking at this function here, I see like there's a quotient, right? Okay, so what I'm thinking of is I'm thinking of using a quotient rule. So as it's been per all my what I do during lessons is I usually take on a very safe approach. I will split it up into first u and v, and I'll write this u to be x and v to be tangent 1 plus x squared. And then what I'll do is I'll differentiate them separately. Du dx equals to 1, and here dv dx. Now when I differentiate this, you can see that you probably will need a chain rule because there's the outside function and there's the inside function. So differentiating the outside function, tangent, that gives me a secant square 1 plus x squared. Now differentiating the inside function, 1 plus x squared, that will give me 2x. Okay, so then finally, using form up my dy dx, using quotient rule, this should be du dx multiplied by v subtract dv dx. Okay, just make sure that the brackets doesn't confuse anything, right? Okay, so that's why some brackets are short and some brackets are long. Is to help you to see. So this dv dx multiplied by u, which is x lah. See, so I'm just going to write it down in this way. Okay, so then over v square. So what's v square? V square will be, okay, sorry, very ugly line. Let me draw again. Okay, let me use a ruler to draw so that it looks presentable. Okay, over v square. So v square is tangent 1 plus x squared. Now I'm squaring this denominator. So v, I want v squared. So I'm just going to put the square here. Okay. Right. So after that, I've written down all my terms. I've listed them out. Now it's time for me to tidy them a bit lah. Okay. So 1 basically does nothing. So 1, I mean, I just scrape it away. So I'm just left with tangent 1 plus x squared on the first term. I notice that there's an x here, there's an x here, that these two are the same. I'm going to unlock them and put them together. Multiply by secant of 1 plus x squared over tangent squared 1 plus x squared. Alright, so I mean, having my endpoint in mind, which there are total of 2 terms, and I have now a big fraction. I see that, I mean, if my numerator basically can be split into 2 parts, right? I can split this into this one fraction into 2. So my first fraction will consist of this section here, and my second fraction will be consisting of the one in blue. So splitting them up, I have tangent 1 plus x squared over tangent square 1 plus x squared, subtracting away 2x squared secant 1 plus x squared over tangent square 1 plus x squared. The one on the left is easy because tangent over tangent square, I can simply cancel out a very nice common factor. Gives me 1 at the top and tangent at the bottom. And looking at the endpoint, you can see that straight away 1 over tangent is none other than cotangent. Okay. Now on the left side, it looks a bit complicated, but I sort of have my 2x squared already planted here, right? Already laid out for me. So I just want to show that secant over tangent square is going to give me cosecant square. So what do I do next? Probably a good way to do proving is, you know, to change everything to sine and cosine. So I'm going to change tangent square to probably sine square over cos square. And similarly, I will change the numerator secant square into 1 over cosine square. Now, just looking at how you see that both the numerator and the denominator has a common denominator, right? Both the top and the bottom have a common denominator. So I can just, seeing both of them have it, I can just cancel it out for both of them, right? And what you're left with is 2x squared at the top, 1, and sine square 1 plus x squared at the bottom. So if you can deal with this, like messiness and ambiguity, then of course what lies at the end of the rainbow is a pot of gold, right? And what is sine square 1 plus x squared? This is none other than just our favorite cosecant square, the endpoint that we've all been dearly trying to achieve. So I have cotangent 1 plus x squared already found. And this just gives me cosecant square. And with that, we are already done with the question. Okay.